Let's walk through everything you need to know to deploy an Azure function using Rust, or actually a Rust application deployed to Azure Functions. I have an example repository here that I'm going to use, and right off the bat, I'll tell you it is kind of tricky because Azure doesn't have native support for Rust yet. What that means is that it's not doesn't have like first class support. It means that things don't quite work, and you have to use some workarounds, some other things that for other languages this doesn't happen. One of the things, for example, is that whenever you're deploying dependencies, for example, in other languages like Python, will get automatically installed, but you don't have those facilities with Rust. So let's get started. Let's get a quick overview of the things that we will need to get this going. So you can definitely use Visual Studio Code. I highly recommend that for trying it out, and you can even deploy from Visual Studio Code, but there's a caveat that I'll show you later. Some of the prerequisites, of course, an Azure account. You have to have Rust installed and available. Make sure that you use something like Codespaces, that is a normalized environment. This example repository has Codespaces configuration so that you have that enablement from the get-go. Azure Functions Core Tools. What this is a separate package. You know, there's the Azure command line tool, but there's also this other special package called Azure Functions Core Tools. Now, what that does is give you all the tooling, the local tooling. I'm going to bring my terminal over here. This is my local terminal for this code, and what that gives you is the ability to have this func command. I'm going to do the help menu here so you can see all of the different things that we have. I'm going to make this a little bit bigger. All the different things that we have here. So why two separate commands? Why something different and separate from the Azure command line tool? Well, this has the exact same runtime for the Azure functions. So if you want to debug, like, why is my function not working? Why are some of the things are not quite, like when I deploy, they don't work. When I run it locally, my code works totally. You can definitely run, create and run functions locally with the same runtime. So behind the scenes, there's a lot of things that you can do here. So something that you can use, not a requirement, but something that is useful to have. All right, so let's go back to the browser and keep going through the prerequisites. Again, the functions, Azure Functions Core Tools, not 100% required on the local side. Visual Studio Code, highly recommend that because it has facilities for Azure Functions. And the extent, because it comes with the extension, or you can install the extension for Azure Functions from Visual Studio Code, which has some nice things. All right. The only requirement, let me see, the last requirement is, well, if you this repository's Codespace is ready, so you can definitely use that. And the other thing that is very, very useful is to use this link that I have here for Azure Documentation. And let's quickly go to that link and walk through very quickly what is this about. So the idea here is that this will give you the some insights on what is it that you need to do to create a Go or Rust function in Azure using Visual Studio Code. Now, the difference with the example that I'm going to give you today is that I'm going to be using, in addition to this method, I'm going to be using GitHub Actions. That is the tricky part, because deploying from Visual Studio Code is just a click of a button and off you go. When you want to try to automate things, things start getting trickier. So let me scroll down, and one of the things here that you might want to do is you select your function language. So this has examples in Go or Rust, so pick and choose what you want, and I'll show you why. Because if you go here to configure your environment, see this tab over here, it says Go. What you need to do is change to Rust, and when you do that, you start seeing that the documentation changes. So make sure that whenever you are here, you say well, it doesn't give you the ability to say Rust, but if you change it right here to this tab, it will change all of the examples. So here it gives you the how to create a local project. Like you can definitely do these. I'm not gonna go through these steps because I've already created the project for you, and I'm going to go all the way here because this is interesting. Now remember I told you that you need to select the language. Once you select it once, all the instructions will have Rust in them. That will make it easier for you to follow these instructions. Now, the dependencies as well are going to be slightly different from my examples. This is using Warp and Tokyo. I'm going to use Actix Web. So just something to keep in mind when you go through that. Then I think this is calling it handler. You can call it something else as well. All right. So good point of reference using the Microsoft Learn documentation. It goes into even creating the application and then running it and seeing how it works. Now I included there because for what we want to do, there's a specific thing that we want to do here that I'll show you. Not code, not the configuration, not the running the function locally, but there's a special caveat that I want to show you. You can sign into Azure using Visual Studio Code, that's fine. The compiling is what I want to show you. So you'll have to have a cargo.cargo/config, and you need to have these put there. So for example, my computer doesn't have this type of processor. So what this is that you will have to compile for Linux muscle. So you need to have this configuration there, otherwise it's not quite going to work. And when you are building, you need to use this right here. So this is the golden tip, and this is why I decided to include the documentation. So this is actually 100% required. So take note of that and use this as a reference. All right, so now we've been through some of the things that we need to do, and now we want to actually, well, not running the application locally, but we want to create the Azure function in the Azure portal. So let's go ahead and walk through what that entails. I'm going to, well, I have the function app right here, but you can also search it here, function app, and it will come up as a service. I'm going to select that. And I have a couple of functions already. You might not have anything running, and that's fine. I'm going to walk you through exactly what this looks like for Rust. So I'm going to go ahead and click create. I'm going to select my subscription. I have a couple. This one is for demos, so that looks okay. I'm going to select a resource group. I don't have anything that is meaningful, so I'm going to create a new one. So I'm going to say demo function Rust, and I'm going to click OK. And prefixing it with demo makes it easier for me to delete the resource group later when I'm done. As you know, the resource groups collect or organize all of the resources for this specific task that I'm going to do, this specific service, in one go. That makes it really easy to just destroy everything at the end of the day. All right, so function app name, this is a domain or subdomain rather of azurewebsites.net, so it has to be unique. So for example, if I do demo, this is probably not going to be available. Someone else just was able to pick that one before me. So one thing that I tend to do is I put my name in it and I say demo Rust Alfredo. That's probably available, and it looks like it is. I get the green check mark, so I'm able to keep going. Now let's, we're going to publish some code, and we need to select the runtime stack, the version, and the region. So what I'm going to do is I'm going to do here one, like you can see, this is where you start seeing the differences between Rust and our languages, and why Rust, what is that difference when Rust is not a first-class citizen here in Azure yet. So you see .NET, Node.js, Python, Java, PowerShell core. Where is Rust? There isn't one. We're going to have a custom handler. So I'm going to click that. The version is custom. Of course it's custom because like there's no version. I'm setting the version of what is it that I want to do. Region is US, seems pretty okay and reasonable for where I am located. You can change that if you want to. And for the operating system, I'm going to be using Linux. Now, the plan type, I'm going to be using consumption. That means that whenever I'm doing some requests, it's going to take a second to bring up the Azure function. Otherwise, if you want to have like something premium, a premium plan would allow you to have something that is running all the time, so you don't have that warm up, that awakening of the function to get that going when there hasn't been any requests for a while. So I'm gonna leave it at consumption serverless because I think there's a lot of requests for free. Okay, so next, hosting. This looks okay. It's the storage account. This is useful if you want to do other kinds of things like attach blobs, or you want to attach certain things for your function. I've created a new storage account that came with everything that I created before, so that looks okay. Let's take a look at networking. I want to definitely 100% enable the public access. I'm going to leave that on. And next, monitoring. Application insights is enabled. That can be useful, and we'll have application insights there created for me. And next, let's take a look at deployment. GitHub Actions settings. So this is interesting because if you want to enable GitHub Actions to continuously deploy your app, you can definitely do that here. I am not going to do that today, and I'm going to show you exactly what it is that I want to use, because there's certain workarounds that you may want to have. I mean, I highly recommend that for now. You can definitely try it out and see how that goes for you, but I recommend just using what I'm going to be showing you today. So actually, you can see here that configuring deployment with GitHub Actions is not currently supported for your selection of runtime stack. So that is why I'm guessing we're getting all of these grayed out. So I guess there you go. It's not even an option. So let's keep going and go to tags. I don't think I'm gonna do any tags. I'm gonna review and create. Actually, let's go and take a quick look. Subscription, that looks fine. Resource group, demo function, this is all going well. So I'm gonna click create and wait until the deployment for this completes. All right, so the deployment is complete. This looks like it's going well. So I'm gonna click on go to resource, and this is fine. Let's take a quick look at some of the things that we have here. The essentials, operating system, this all looks okay. Memory working set, well, it's 0 because there's nothing going on right now. Let's take a look at megabytes per milliseconds, function execution units. This all looks okay. Let's take a look at functions. And we don't have anything yet. So what is the deal? You might be slightly confused with this because the thing here is that we've created the service, and the service can have 0 or more functions. So you can actually go ahead and create your actual function within here. So you can go and say, well, I want to create it with VS Code, or I want to use some other editor, and that's fine. You can certainly do that. So that is why using Visual Studio Code it's a good choice to initially get that deployment going, but that will allow you to go ahead and get that created and make one of these functions appear in the service. All right, so you can definitely try VS Code, as I was saying, but the thing is that with VS Code is manual deployment. You can definitely try that, and it'll walk you through everything you need to do. And actually, if you remember, the documentation also walks you through to how to do that. What's the problem with that? Well, it's manual. Like the next time you need to deploy, well, you have to have your laptop, you have to have your environment, even if it's code spaces, you have to go through this process. Automation is key, and automation will save you from making mistakes. So we're not going to use VS Code. And I know you might be wondering, like, why am I going through all of these workarounds or going around these VS Code and how easy it is. And actually, I want to show you VS Code here, which is the exact same. And let's open the README so that you can actually get to see these. I want to show you like how does this look in VS Code. So if I go to Azure here, you'll see that this is demos, and you'll see that now my resource group appears right there, and I can click there and I can say demo. Oh yeah, that's actually the one that I just created. So if I click functions, it will say, I don't need to know my workspace. Well, this is my workspace, application settings, files. But look at my workspace right here. And I know it might be tricky to see, but you can actually go ahead and this button is to create a function, that little thunder, and you can upload files and deploy them, or you can even download a file. I don't know when to download, but you can actually go ahead and deploy to Function App. So I can click that one, and then you go through the different steps, and it tells you, hey, well, like, which one do you want to deploy, and it'll guide you through. You can definitely do that. But we're not going to concentrate on that. We're going to do some automation. So what is it that we need to do? Let's take a look at what the documentation tells us that we need to do. And I am going to go, well, the documentation actually doesn't even tell you that other than VS Code. The compiling is it's important. Creating the function app in Azure, it completes, and then you're good to go. And then it tells you, like, you're deploying. This is the little cloud with the arrow that I was showing you earlier, and then you can see the output, and then you run the function in Azure. That's it. So what does it take to run these on with GitHub Actions, which is the automation that I'm going to be showing you today? So usually with functions and some other services in Azure, you'll get something that is called a published profile that you can see right here. So the published profile, it's an XML. It's an XML file that you will get and then you can use. Now, why is that important? Because there's GitHub Actions for deploying applications like Rust, like other applications as well, like Python, that will require you to have a published profile. And tell you what, and then you add that. It's an XML file. Sorry, it's an XML file that you will download and then add as a secret. So, what is the next step here? The next step is that we need to actually create a service principal. So what is a service principal? It's a special type of account. I'm going to go back to the repository and I'm going to show you this one, deploying with GitHub Actions. So the first step is running a command like this. Let's walk through, if you never created an Azure service principal, let's walk you through everything you need to know. So you need to have, you actually can use the Azure shell. Like if I go to here, see this thing right there. So if you click here, this will pop up. Cloud Shell works up. So why is this useful? Because it will be already authenticated. You don't need to do anything special, and it will allow you to run the command. So you run that command. So I'm gonna show you back here. So AZ, you'll have the Azure CLI installed. AD stands for Active Directory. SP stands for Service Principal, and you're gonna create for RBAC. RBAC stands for Role-Based Access Control. You're gonna name these something meaningful. In this case, Rust Azure Function seems okay. SDK auth is just a flag. What role? Where we're gonna create this a contributor role. You need to know what your subscription ID is, and if you want to tighten down the permissions, tied it down to the level of the resource group name. Remember, we created a resource group with demos, prefix with demos, so that way this account is going to have permissions to do things in a contributor-based access for that resource. So you run this, and you will get an output that looks like, well, it's JSON, and it's going to look something like this. You capture that, you select from here and from there, and you grab that and you save it as Azure_credentials in a secret for your repository. So how does that look like? So if I go, once you do this, let's quickly go scroll all the way to the top, go to settings, and then scroll down to security, and then find secrets and variables right here, and then click that one, select actions, and then add the add new repository secret. Now I already have the Azure credentials that you see here, and in fact I also have the Azure Function App published profile. Now you may be wondering why does he have like two of these secrets if the published profile I just told you like you shouldn't use? Well, I know not to use it because like I already tried it out and there's some problems with the published profile and using the GitHub action. But for what we want to do for this thing to work, you will need the Azure credentials. So the Azure credentials, once you go ahead and create the repository secret, you will create it with a name and then the value. In this case, Azure_credentials is already been created. So I'm gonna go here, and if I wanted to edit that, this is how it will look. I will paste here the new value. I'm not gonna edit that, and but that's how you add one. All right, so let's go back. Let's go back to the repository. Let's scroll down to deploying with GitHub Actions. So you capture that, you add it as a secret. What is the next step? Well, the next step is to actually go and use GitHub Actions, and I'll walk you through everything that you need to know for GitHub Actions and how to get that. Now, I added a section about caveats, and I will discuss some of these once we're done with the deployment. But just know that there's certain particular things and workarounds that we're doing. You've already been aware of some of the things that I'm skipping or trying to work around. So let's go to the GitHub Actions and see how the failing deployment strategy that I had initially looks like, so that you have a good understanding what's the current state. All right, so this is my failed deployment YAML file that was using the published profile. Demo Rust of Alfredo was the one that I was using at that point in time. I was using Ubuntu latest, that's fine. I check out what's the code from the repository, and then I install with this rust up command. So I go ahead and use rustup.rs and grab that with bash and then install that on the system. Then a requirement, and this is actually also in the working version, you have to install Muscle, otherwise you will get into trouble because you won't have the linker will not be there. Then I add the target. Remember, we saw in the documentation that you have to add the target with rust up, so you have to add these, otherwise it won't work for the Azure Functions environment. Now for build release, you'll build with using the target for x86-64, and then you'll copy the resulting binary, which is, I also named it handler. You will copy it to the top directory. That's what this whole command is doing. Now I tried using these actions -rs toolchain that supposedly was able to install the target and set the target and override and set it as a default. I couldn't make it work. That's why this is commented. So if you find this and you think that this is a better alternative, maybe it works for you, but like when I tried it, it didn't. And it seems like this is going now kind of like unmaintained, so I don't recommend using it. Similarly, actions-rs has a cargo action. It seemed like that was working, but I ended up not using it and just going with this setup right here. All right, so going continuing on the failed deployment strategy, I copied the handler to the parent directory. That is a requirement. I think this is repetition from what I had above, but that's fine. It doesn't really matter. And then this is the action from Azure. And this is where there are certain tricky parts. This right now for Rust is not quite working. There's an open issue, so it's linked in the repository. So make sure you check that in case you see this and you want to try it out, because it definitely looks appealing, right? Like it's 5-6 lines of YAML, and then that's where you will use your publish profile. You need the function app name, the package name, or the path rather, which is dot. It's the current top directory. That's why that copy is important. And then the publish profile is the thing, the XML thing that you download from Azure. All right, so that's the failed one. So let's take a look at the correct one that I know it works, which is this one, main.yaml. So this one is called deploy Azure function workflow dispatch. That if you don't know, it's the ability to trigger this manually. And you have to capture the Azure Function App name, the group name, and the package path. Now, the package path is fine to leave it as is, but make sure you update these two, one for demo function and the other one I have for demo Rust Alfredo. Now, if you remember, I keep creating many different group names. I don't have demo-function. If I go back to here, you'll see that this is demo function Rust. I'm going to copy to the clipboard, make that update really quick, and make an update here and say this is not demo function, it's demo function Rust. I'm going to commit the changes and make that update. So that looks good. And I'm going to keep scrolling down. Let's go through all of these steps. First is we clone the repository, we install Rust, we install Muscle, which is a requirement to build and add a linker. We add the Linux Muscle target, and then we build the release. So we do run with this command, cargo build -- release. We mention that's the target. Then we copy the handler to the parent directory. That's what the dot means. Then we set up the repository. This is the tricky part. This took me a while to figure out because it's the one way I saw that we could make this happen. What is going on with this repository here? Well, we are going to add a special repository for Ubuntu for this architecture, and it's going to allow me to install certain packages that are coming from Microsoft. What are those packages? This one right here. The Azure Core Tools is the one thing that I need. Now you may be wondering, like, why am I installing Azure Core Tools if that's for local development, that has the local runtime? Well, Azure Core Tools also has the ability to deploy, and this is the one way that I saw that you can actually deploy Rust to Azure Functions with GitHub Actions by using Azure Core Tools. Now, the Azure credentials that you capture with the service principal and you saved as a GitHub repository secret, that is what we have here, and that's how you authenticate. So once you authenticate, you're going to be able to deploy to Azure Functions. And how you do that? Well, it's a single line. It's this one, func Azure Function App publish. You have the function app name, and then -- custom is crucial so that this understands how to handle that. It understands that this is a custom runtime and that it needs to do everything correctly. So let's go ahead and scroll all the way up, go to actions, and try to make a run. All right, as you can see here, I have plenty of failed deployment runs. Some of them succeeded, but they were not quite working. So the one action that works actually is this one, deploy Azure function, and it has a workflow dispatch event trigger, which as I mentioned, it allows you to run this manually. So let's trigger manually, not run manually, but I'm gonna click on run workflow and let it run, and hopefully this will show up here, and we'll take a look at the logs. There you go. That's already here. It's appeared as deploy Azure function, manually triggered. It's building, and it will go through all of the steps. So we'll wait until that completes. While we're waiting for this, what we're going to do is actually walk through the code and see what are some of the files here that we're dealing with and what is exactly going on. I mentioned that I'm not using Tokyo, which is the web framework, one of the popular web frameworks for Rust. I'm using Actix Web, which is another web framework for Rust. So let's start with the dependencies. So cargo toml, and you'll see that I named this handler, as you know, because we were copying the release build. The dependencies, we're using Actix Web. We are using nlogger and cert for serialization of JSON, and we're using this package for doing checksums. So why are we using checksums? Because the API is we're sending a string and we're getting we're serializing the response to get a token back, to get essentially like a hash of the string that we're sending. That's the whole code. So next, let's take a look at some of the function configuration settings. This one, you'll see that we get the custom handler. This is all, I didn't write this from scratch. You get all of these when creating. You can get the same thing by creating creating the function, the scaffolding with Visual Studio Code. That's why Visual Studio Code is so good. You will get the same thing. But if you're reusing this repository, you don't need to do that. It has everything already configured for you. Func_ignore is a useful one because it allows you to skip certain things that you don't want to push, like this one, prevent publishing the content of the target folder. That's crucial because you don't want to push all of those files. So let's go and take a look at source. And I just have like a main that rs file. I could have done something a little bit different. I'm gonna close these and I'm gonna keep scrolling. So let's walk very quickly what is going on. We have a very simple function that takes in a string and returns a string. And what it does, it creates a digest, creates a new one, and that's creates a version of that tokenized or creates a hash rather from the string that is incoming. Cert here is allowing us to do the serialization and deserialization. This one's the deserialized, this one's the serialized. So this is incoming. Actually, this is incoming and this is outcoming. I got it backwards. And then we're going to get text and then a string, and then we're going to return hash with the string, with the resulting hash of the string that we want to do. The main one doesn't going to do anything other than set up the login environment. These ones are actually pretty important and something that I borrowed from the documentation. So you're going to have you have to have a mapping of the port where your application is running to the one that is expected from Azure. So Azure will set that with this environment variable called functions custom handler port. And what this section is doing is saying, hey, let's take a look at that environment variable. And if you find it, then that's fine. Then assign it to port. If you don't find it, just use port 3000. That looks okay. And then we start the server, and you can see here 0.0.0. You're binding to anything, and the port is coming from this guy right here. So that's it. So we're getting one endpoint, which is API token, so API/token. We're receiving a string as input, and we're returning a string as output. All right, so that's it for the application. There's nothing else. It's a very simple bare bones project on purpose, so that you can actually build on and do more complex stuff with Rust and Azure Functions. Okay, so the build completed successfully. That's great. Let's see how much it took. It took about 5 minutes. You can see here 4 minutes and 50 seconds to build it. You can improve that with a little bit of caching if things are not changing too much, and reusing certain pre-installed packages. That looks fine. Let's take a look at this one, deploy to Azure Functions specifically. I'm going to click on that one, and it's going to say publishing info, uploading the package. It uploaded 3.44 megabytes of files. That's impressive because it's not a lot, and like in a good way. I think 3 megabytes, almost 4 megabytes, is pretty excellent. And this is the invoke URL. So what we need to do is, like, if I click on that one, you will see that probably there's nothing. Well, it's requesting API token. If I run just the URL, you will get this, your functions for that zero app is up and running, which is great, but I want to invoke it. So let's go ahead and use the terminal. For the terminal, I don't have any authentication. I'm going to use curl, and I'm going to use content type application JSON, because if you remember, I'm sending JSON. Let's walk through what I'm doing here. Verbose, yes, I want to have everything. I'm passing the header, which is important because it's JSON. I'm doing a post request, and this is the data text. I'm passing a string, and this is the URL. All right, so let's run it, and pretty fast. The response, actually, like, I got a 200, as you see right there, but the response is this one. Let's pass something else. So we can say, for example, we can say demo, and then we will get some other hash. So that's good. It works. So let's go back and see some of the things that you might be interested on the Azure portal. All right, so this is the Azure portal. This is my function. Let's take a look at the functions here. Remember, before we didn't see anything. Now this one appears. So you click this one, you'll see things are actually moving very well. Total execution count, we have 2 times. We did 2 requests. Actually, that looks okay. Failed execution count, we don't have anything failed. We only have 200s, no 400s, no 500s. So that looks pretty good. Like, you can get the function URL, you get all kinds of different things here. So I'm gonna close that. I'm going to go now. I want to show you, if you have issues, if you have problems, where would you go? Well, there's lots of configuration things that you can change here, and you can add. You can change the settings. You can set, for example, certain environment variables here as well. But you can actually set those with GitHub Actions, and set the environment variables so that you know certain values at when this is running. Actually, the Azure function is actually running. But I want to show you. Well, you have scale out, which is also pretty neat. You can set the scale out to do really, like, you have dynamic scaling out, which is really nice to see. All right, you can see the service plan, but I want to show you the logs, and you have plenty of different things because we set up application insights, remember, but I'm going to show you log streams. So if you click this one, it will load, it will take a second, it will try to connect. So now it's connecting to application insights, but behind the scenes, what it's doing, it's trying to connect to the live streaming logs. So let me try to do a couple of requests and see something pop up. So I did a couple of requests there very quickly, and let's go back to application insights and see some of the logging. So back on Azure, you can see that there's a lot of, well, not a lot of output, but you can see that request successfully match, token and template API token, perfect, invocation ID, succeeded. And these right here that looks like an error, it's not an error. It is, I believe it's capturing as error because it's going to standard error. You can see that this is actually coming from Rust. It's saying, hey, this is the middleware. Remember, I have that logger env package or crate. That's what you're seeing here. So there you go. That's it. It's been deployed. It's working. Now let's take a look at some of my notes on why this might be a caveat, some of the caveats, some of the problems that you might face. So you must select custom. Remember on the scaffolding as well, like if you're creating this from scratch and you don't want to use my example repository, you want to use custom. Deploying using GitHub Actions for function does not work, and the workflow will succeed, but the function will time out when invoked with an HTTP 500. That's the worst kind of error because you are not getting any visibility. The application simply times out. So the workaround is to use Azure Core Tools, as you saw, and the workaround, this implementation or this repository, example repository, is a workaround until the GitHub Actions for functions is fixed, which I've linked over here. So that's it. Hopefully you can build something more powerful, more complex that does many other different things, and it allows you to deploy and take advantage of Rust in Azure using Azure Functions.